Okay, question 9. We're given that the number of bacteria in colony A is modelled by the function a of t equals 12e to the 0.4t. In part A, we're asked for the initial number of bacteria in the colony, so we're looking for the number of bacteria when t equals 0. When t equals 0, a of 0 equals 12e to the negative 0.4 times 0, which is 12e to the 0. Anything to the power of 0 is 1, so we've got 12. Okay, in part 2, we're asked how many bacteria there are in the colony after 4 hours. So, we're looking for a of 4. As before, 12e to the power of 0.4 times 4. We've got a couple of ways we could do that. We could simply work out 0.4 times 4, calculate it on the calculator, it gives you 59.4. We could alternatively have a look at the graph. We could go to second calculate. We could look for the value when x equals 4. Hopefully that'll give us 59.4 as we got over there. Okay, 59.4 in fact doesn't make sense. The number of bacteria would be, so 59 would be the answer. 59.4 bacteria doesn't make sense. Okay. Part C. Part C, we're looking to see how long it takes until there are 400 bacteria in the colony. So we've got the same function, the 12e to the 0.4t, and we're looking for when that equals 400. Okay, we could do some rearranging, but I think the easiest thing to do is to go back to your calculator. We want an extra function, so y3 equals 400. We're going to have to make the window a little bit bigger. The y max we're going to have to go up to at least 400, maybe we'll make it 500 so we can see what's going on. That means we're probably going to have to make the x-axis a bit longer. Let's have a guess that we need to go up to 20. Look at the graph again. And hopefully we can see the intersection. We can. We go to calculate, intersect. The first curve's correct, the second curve's correct. It's roughly where the cursor is, and the intersection is at 8.77. So t equals 8.77 hours. Okay, and in that case it does make sense to leave the answer as a decimal. Okay, change the pen. Part D. Part D, we've got a different colony modelled by a different function. It tells me that after 4 hours, well, the function is this, e of t equals 24e to the kt. And it tells me that after 4 hours, so when t equals 4, the number of bacteria is 60. So if I substitute that information into the equation, I get 60 equals 24e to the kt, or to the 4k. Okay, again, I could solve that algebraically, or I could solve that on the calculator. On the calculator, we'll get rid of that function 60, which we don't need it, 400, sorry, which we don't need anymore. We'll make it 60. Here's a formula I typed in earlier, 24e to the, we want to make that 4x, delete the rest of the formula. We're not interested in y1 anymore, so I'll turn that off. And we'll have a look at the graph. And we can see the intersection there, but it's not very clear. We'll change the window. Let's have x just going up to 5. See if that makes it any clearer. seems to have caused my calculator a problem. Okay. Well, in fact, if you try that on your own calculator, you should find that k equals 0.229. Three significant figures. Okay. Finally, part E. We're looking for when the number of bacteria in colony A first exceeds the number of bacteria in colony A. So, the number of bacteria in colony A was given by this. We want that to exceed, so we want it to be greater than the number in B. The formula, the function for colony B is 24e to the 0.229, that's the value we found in part D, times t. And we're going to try and solve that on the calculator. Hopefully this will work this time. But apparently it won't. Okay. If you plot those two graphs, you find the intersection, you find that you find that this function on the left is greater than the function on the right when t is greater than 4.06. And since in the question it says that t, or the number of years, has got to be a whole number, then we're looking for t has got to be greater than 5, or t in fact equals to 5. Okay, sorry about the problem with the calculator.